Hi, welcome back for another 6 Caillou challenge. This is called Sudoku Board Validator. Hopefully you know the game Sudoku. It's this 9 by 9 grid where, let's just look at the examples section below. You'll commonly find this game in newspapers and things like that, where of course all the numbers aren't filled out. They give you a few to start and you've sort of got to come up with, you've got to fill the whole grid with all the values. They have a nice reference here, so why don't you go ahead and read about that if you aren't familiar with the game. But basically what we have to do is write a function or implement a function to validate a board that has been filled out to make sure that it is correct. And the idea with Sudoku is that you use the integer values 1 through 9 exactly once in every row, also in every vertical column should have the values 1 through 9 in any order, and then each of these little squares, these 3 by 3 squares here, also contain the values 1 through 9. So remember, you have to check all of those, all 9 of these, this square, this square, this square, this one, this one, this one, this one, this one, this one, and then every row in every column. That's basically what you have to do to validate. So why don't you go ahead and pause the video, try this out, come on back when you're ready, and I will get into my solution. So nothing fancy here. I'm just going to do what I said I was going to do, or what I told you to do, is to just verify every row, every column, and then every square, all 9 of them. So let's see, how can we do that? We're given this array of arrays, if you will, of integers here that represents the board. So let's go through and if you want to see an example of this, you can look in the sample test, see how they give you these, all of these arrays size 9. They give you 9 of them to represent the board. I didn't do any input validation and was able to solve the problem. So if you want to treat this like a more realistic scenario, you could validate that each array is size 9, which is the proper board size, but you don't have to do that here. Always good to think about though, right? So let's go through each of these arrays to start. And for the purposes of verifying this, I'm going to add a private static, we'll make it an int array, and I'll call it valid span. And so this is sort of the benchmark that I use to check every little grouping of values I pull from the board, whether it's a row, whether it's a column, or whether it's a square. And then let's just populate this with the numbers 1 through 9. Remember, range, enumerable range, you give it a starting value and then a count of how many consecutive integers you want to go up to. So this should give us 1 through 9. And since I made this an integer array, range would return an enumerable of integer, so I'll convert it to an array to make that match. Okay, so now every row or column or square that I pull, I can just compare to this and make sure they match. And that will be how I sort of validate each individual section. So let's get those rows first. We could say for each int array, well, I'll call it a line, or you could call it a row in board. And then let's make sure that each of these contains the values 1 through 9 exactly once. And so to do that, we could say, we can use a handy enumerable method called sequence equal to sort of handle this. So what I can do is, let me see, I had the reference page pulled up for you here if you want to reference this. Determines whether 2 sequences are equal according to an equality comparer. And since we're working with integers, that should already be implemented on our behalf, and we don't have to worry about that. Let me see if they have an example for us. They do, with some pets here. These sequences are equal. You can see they both have the same pets, have the same values. So they're using custom types here. We're just going to use integers. Feel free to read through this all you want, but it's just, I wanted to show you that's the sort of method I'm using to verify that. So let me get back to this. And then we can say, for each line, we could say, oops, if um, enumerable, and I'm actually going to negate this because I want to return false. Remember, as soon as we find one span that doesn't have the values 1 through 9, we can stop evaluating, right? Because even if everything else is perfect, we know the board is invalid. So I'm going to sort of flip this. If enumerable sequence equal, and then I'm going to say line. And what I'm going to do with line is I'm going to order it because this is ordered, right? If I had, even if the if the line were valid, but the numbers were sort of rearranged, they didn't go consecutively from 1 to 9, the sequence equal wouldn't match with this one. So all I'm going to do is say line order by, and then I'm just going to say order by the value itself, right? Each element is an integer, and just order by. Remember, order by default does ascending, so it'll do 1 through 9. If I had descending, it would go, there's another method called descending if you needed to order the other way. So then, yeah, line, put the line in order and make sure it is equal to valid span. I use the word span generically because we're going to be looking at both lines and columns and squares, so I was just trying to think of a generalized term for a collection of values. Oops, I don't want a semicolon there. So if not, let's return false, right? If any one of these rows is invalid, we can say, hey, this whole validate of the board is invalid. That's the idea there. So good. That's the sort of the easiest part of this, just doing the lines, just grabbing the int arrays as they are. You can imagine when we get to the columns, though, we've got to sort of go vertically, right, for each position to get the column values. And so that's a little more work, but it's not bad. We can go ahead and do that next. So let's see, how can we handle that? Let's make another for loop. We can say for int I equals 0. I is less than board.length, which better be 9. And increment I. Okay, so now how can we get a column? Let's think. Well, to get the column, we're going to sort of go through each integer array and we're going to grab the first value from it, right? So let's sort of make that var span, I'll call it, equals board.i. We want to grab brackets I. We want to grab each line, board line, board I, and then, actually the way I want to do this is, let's do this. What we're going to do is use enumerable select method. Remember, this projects each element of something into a new sequence. So board, remember, is a collection of integer arrays, right? It was an array of integer arrays. So you can think of it as each element of board is an integer array. So I'm saying, okay, I've got each of these. I'm going to name it line. That's the variable name I'm going to use for my line. I'm going to just call it line. And then how do we want to process each of these lines? Well, I'll just say line position I, right? For the first time, it's going to be 0, meaning take the first element from each array, right? When I is 0, it's going to say take the first element from each. So I'm going to do this, and you can see it's going to go through all 9 arrays, grabbing the first element of each the first time around. The second time, it'll grab the second element from each, then the third element from each array. And hopefully you can see how that's building each column. But we're going to look at each of these columns one at a time. In fact, if you want, you could call this column if you like. So good. All right, now we've got to basically do the same kind of thing, right? We've got to make sure our column contains valid values. And so what I'll do is I'm going to do the sequence equal thing, but even right here, as I produce each column, I'll just go ahead and order by at this point. You could do it like we did before as part of the sequence equal method, but I'll just order it here, and then I can say if not enumerable sequence equal, And then we could say column invalid span. Then we know, hey, you've got to return false. So good. Something like this should give us, it should validate each row in each column, and that will leave us left with validating each square. Now what I'm going to do is I'm going to stay within this for loop here that goes from 0 to 8, and I'm just going to think of each of these squares as having an index value. So I would call this upper left index 0, upper middle index 1, upper right is 2, middle left is 3, 4, 5, 6, 7, 8. And then I'm just going to use this index again to check squares. I'm just doing it in the same loop. I could come outside this loop and make another for loop and do that, but since I already have a for loop set up the way I need it, I'm just going to check each square as I check a column too. So same kind of thing. Let's do that. So what we can do is we can think of it like this. I could say var square span equals some method I'm going to make called get square, where I pass it an index value and I pass it the board so it can access the values on the board that it needs. Something like this. And then the idea will be the same, is that I got to make sure that square span is valid. So what I'll do is I'll copy this, paste it down here, and then of course we're not going to check column again. We already checked column. Got to make sure we're checking our square span. Okay, so that's fine. And then to finish up this method, the top level method, the idea is if we don't find anything that violates a valid span between the rows, columns, and squares, then we return true. If you can survive all the way through these checks, then we say you have a valid board. Okay, that's great, but we've got to implement this, right? So let's do that. We could say private static int array is what we're going to return. I'll say get square, and it needs an index value and a board of values to work with. And I'm not actually going to implement each square in here, so I'm going to defer that. I'm sort of stepping down incrementally to getting to the lower level functionality here. This is just going to be a method that at a higher level will just say it'll switch on the index, and I'm going to make all these cases like this. If case 0, I'll say get upper left with the board. And I'm just going to repeat these 8 times for all the positions. 5, 6, 7, 8, 9. And then I'll also make a default case as a safety, just as a best practice. Default, if it isn't any of the index values that we need, I will say throw new argument exception something meaningful. Don't actually write that, but whatever you want to put something in there that's going to help you get to the root of the problem very quickly. 3, 4, 5, 6, 7, 8. Okay, and then of course we don't want get all upper left. It would be upper center, upper right. I'll call it middle left. I'll call it middle right. Actually, I'm middle center. I skipped one there. And then it would be middle right. Then we'll call it lower left. Then it'll be lower center. And then lower right. Okay. And so that's all I'm doing here. I could have implemented each of these in here, and they're mostly the same, but then it would have made this method quite large. So I'm just kind of breaking these out into pieces. And the idea will be I can do private static int array. That's what we're going to return. Get upper left takes a board of values. And so how can we actually implement this? So to do these, they're going to take a very similar form, and I'm just going to do something simple here. For the upper left, right, we clearly need the top 3 rows. So I could say var first equals board 0, that first array. And I'm just going to say take 3, meaning take the first 3 values of that. And then I can just repeat this for the second and third. Call it second, third, and then you'll see I'll just concatenate each of these together. I can say there's a concat method we can use, and maybe I'll order them here too. So I could say return first concat second concat third, and that's just taking the 3 values from each, the 3 values from the first row, the 3 values from the second row, 3 values from the third row, putting them all into one collection of size 9. Then I can order by here, just like we did before, just order by the values themselves. And then remember, all these enumerable methods, they return IEnumerable collections, and I specified an array specifically here, so I will convert them to an array. And then basically I just repeat this for the other ones, and we just got to tweak, which rows we're using and where we're taking the 3, right? It won't always come from the front. So as I do this, it's going to be slightly repetitive, so if you want to speed up the video, you're welcome to, or if you just want to watch with me and maybe code along while I'm doing it too, that would be a good exercise. So next we knew it was upper center. Okay, so upper center, right? It's going to be very similar. We're still taking the first 3 rows, but let's do this. Let's skip the first 3 values, then take 3. Then it's going to give us the middle 3 rows, right? So we'll just repeat that skip 3 for each, take 3, and then everything else is the same, right? And then you can imagine for get upper right, instead of skipping 3, what do we do? Well, let's skip 6 and take the last 3 values for the upper right. Skip that. Okay, and then it's the same. So what I'll do now is, since I have these 3, let's do this. We can say copy this whole thing, paste it, and then now instead of uppers, these are middles. Middle left, middle center, and I want you to start thinking already about how you're going to modify these to make these middle. Oh, one big mistake I made. We're not always taking the first row, right? We need the first row, the second row, and the third row. First row, second row, third row, first row, second row, third row. Okay. So now here, we don't want the first 3 rows for the middle, right? We want rows 3, 4, and 5. So let's do that. 3, 4, 5. We want 3, 4, 5, and 3, 4, 5. And then again, we can grab these 3 to do our lower collection. Paste. Let's call this lower left, lower center, lower right. 6, 7, 8, 6, 7, 8, 6, 7, 8. And that would be the bottom rows, row 6, row 7, row 8. Remember, we have 0-based indexing, but basically it's the same thing. So now we should have all of these methods from our general get square method implemented, and that should make this valid. And assuming I didn't make any other mistakes, something like this. I apologize, I should have expanded the screen. I'm still getting used to that and just coming back after hiatus there, so I'll try to do a better job of that in the future. Let's go ahead and test, see if I type things correctly. Okay, so enumerable, right? We're using enumerable, which means we know from that when you want to use that, you have to bring in the system link namespace. So that should clean up that error using system link. I'll just hit test again. There'll be more errors, but those are my dogs barking in the background. Hey, pups, we're doing a video here. Line 10, the name line does not exist, so 10, what did I do here? And, I called it row, didn't I? So we'll say row order by to get rid of that error. The type or namespace argument exception could not be found. You could look that up in the docs. That'd be a good exercise, but I know that it's using the system namespace. What else do we have? Cannot fall through from one case label to another, so I messed something up with my switch statement. Let's go look at that. Switch index case 0. Oh, sure, I just put get upper left. What I meant to say was return. So let's add those returns. Okay, let's test that. And there we go, there's the green we wanted. And submit, we are golden. So we'll do a quick review of this. The idea is that for Sudoku, you've got to check rows, columns, and subsquares. We handled the rows here. We did our checking by sort of creating this collection of the values 1 through 9, which are required for each span to be checked. I had them in order here with my range thing, so that's why I always had to use these order bys to make sure that when I invoke sequence equal, it could work the way I intended it to. So we checked rows, we checked columns, and then we checked subsquares. And you can see the general idea was the same. We just used sequence equal. We treated each of these rows, columns like generalized spans that we could compare to this sort of idealized span. And then for get square, instead of dumping a lot of functionality in here and making this validate function really long, we took one step down and said, hey, let's have this get square helper method. And instead of actually getting the squares values, we'll just sort of slowly step down into that. We'll just route the request to the appropriate square, and it kept this method small in size, and then we've got a bunch of methods that are just a few lines long to get the actual values in question and return them as an integer array. So I didn't use any comments. If you did, this would be your opportunity to remove those. I'll probably fire mine off like this. So minimize. But yeah, you could see there was nothing fancy here. I just sort of walked through the way that you would check a Sudoku board if you were doing it by hand. You would check the rows, you check the columns, and you check the subsquares. So let's fire this off. Get your honor points. And yeah, look through some other answers and see what you can learn. Look how compact this answer is. Array sort. Okay. A lot of work there. Yeah. So you got some variation there. There's some stuff to chew on here and consider. Otherwise, I will see you in another video. I appreciate you watching, and take care.